Okay, here we go, ladies and gentlemen. We're going to do it on, or I'm going to make a video here on differential equations and slope fields. We're not going to do Euler's method in this video, but it'll be one that's upcoming. A differential equation is simply an equation involving a derivative. Hence, any derivative of a function is a differential equation. Okay? Solving a differential equation involves integration or antiderivatives. Okay? So we're going to use three methods. We're going to do integration using anti-differentiation, including initial value problems. Euler's method, not here, or not today, but slope fields. We'll do 1 and 3 today. Okay, so we want to first determine if y is a solution to this differential equation. Okay, so all we're going to do is we're going to find y and substitute it here and use y prime and substitute it here and see if they're equal. If it is, then it is a solution. Okay, so y prime is going to be, well, it's 1 times e to the 2x plus 2x e to the 2x. Okay, so that is e to the 2x plus 2x e to the 2x. All right, so I'm going to go plug this in. So if I'm going to substitute on this side, so I get e to the 2x plus 2x e to the 2x. Does that equal 2 times this? And it clearly does not. We're missing this term. So is it a solution? No. Okay. All right. The second one is this one. All right. So first of all, y prime is going to be 5e to the 5x. So that's what's going to go over here is 5e to the 5x. Does that equal, I guess I should have put a question mark here, 5 times the original function is what that means. And yes, they are in fact equal, because 5e of the x is equal to 5e of the x. Therefore, is it a solution? Yes. Okay? So all it is a verification. Nothing more than that. Okay? All right. We've done antiderivatives. So this is really what 1 is here. We've done antiderivatives. But we're now going to have the so if the antiderivative of little f is big F, we rewrite it as big F plus some constant. If we're integrating f prime, then we get just f plus some random and arbitrary constant. We said f of x is where f of x is an antiderivative of f of x. Note dx means we're integrating with respect to x. Okay, so and there are a couple of minor things we have to do here is to solve this for f of x, I'm going to have to integrate this side and integrate this side. But in order to integrate, if you remember, I have to have a dx here. Otherwise, I cannot do the antiderivative of it. And I just did the same thing to both sides. All right, so the antiderivative of f prime, as we all know, is just f. And by the way, we get a plus c there, but I'm going to address this in just a second. And on the other side, I know it's x to the fifth, and there's now a 2 out front. Okay, what function is the derivative of sine? We know is cosine of x, and it is positive because when I differentiate it, I get a negative. And then the antiderivative of 6 to the x, we know is going to be 6 to the x, but there's a natural log of 6 on the bottom, and there's plus c. Okay, now you notice that there's a c on both sides, but we only really need to account for it on one side, and we're always going to put it over where the function notation is not. So our final answer is f, because by the way, a constant and a constant is still just a stinking constant, so we look at it. Okay, so I get 2x to the 5th power plus cosine of x plus 6 to the x over the natural log of 6 plus c, and that's my answer. Okay, we just integrated both sides. All right, so if you look at number 2, by the way, dy is going to stay here. We're going to multiply both sides by dx or move the dx to the other side. So because I'm really what is known as separating the variables. And this is really 5x to the negative third dx. Okay, so I just separated that dy and that dx. So I'm going to integrate this side, integrate this side. Well, the antiderivative of dy is really 1 dy. So I just get y is equal to, well, I know this is going to be x to the negative second because I'm increasing the power by 1. And then it's 5 over that number plus c. Okay? And then as that antiderivative, you notice we're always putting a plus c here. There really is one on both sides, but we're combining it into one and leaving it only on one side. Okay, so number 3, we're trying to find y of t, which is really what we get. We could have had this as y of x, but so let's separate the variables. I'm going to bring the dt over here and then integrate. So it's going to be dy is equal to, and this is really 4t to the 3 halves is what I'm integrating, plus the cosine of t plus 1 over t dt. Okay, I can call this y, but in this case, we're just going to call it y of t instead of y, because this is really y of x. So the antiderivative of this one is y of t, or you could just say y, is equal to, we know it's going to be t to the 5 halves, and then it's 4 times 2/5 here, because it's reciprocal, plus the sine of t, because when I differentiate the sign, I get a positive. And then, remember, the antiderivative 1 over t dt is the natural log of the absolute value of t plus c. So really, if I work this out, I get y of t is equal to, well, that's 8/5 t to the 5 halves plus sine of t plus natural log of the absolute value of t plus some constant. Okay? All right, so let's go do number 4. All right, we need to rewrite this one. I'm going to move the dx over, and I'm going to write this with exponents instead. So I get dy, antiderivative of that is equal to, this is x to the 3/5 plus 2x squared plus 8 over square root of 1 minus x squared. Oops, x squared, and then I have dx here. All right, antiderivative of this is y, or y of x, it doesn't matter. And this becomes x to the 8/5, because I added 1 to it. And its reciprocal goes out front, which is 5/8. Plus this is x cubed, and so it's going to be 2/3 of that. And then hopefully we recognize that this is an arc sine, so that's plus 8 arc sine of x plus c. And that's the solution to that differential equation, or finding that antiderivative. It's really the same thing. Okay? So that's that page. All right, so if I go back over here, so we're going to do initial value questions here. All right, so number 5 says we're going to find y when y prime is this. And we're also given an initial condition. Okay? So we're going to start out with, this is really dy dx. So I really have dy dx is equal to 2x minus 3. And now I got to separate the variables, so I'm going to bring the dx over here. So I get the antiderivative of dy is equal to 2x minus 3, antiderivative of that dx. Okay? So therefore, y is equal to, and we're going to do the antiderivative of that, is I get x squared minus 3x plus some constant. So everything I did would remain the same, but now I'm going to go apply this and actually find out what the constant is. Okay, so I'm going to make y is 10 now once I did the antiderivative, and x4 and figure out what c is. So when y is 10 is equal to that, 4 squared is 16, plug in 4 there, I get minus 12 plus c. So 10 is equal to 4 plus c, so c is clearly 6. So I'm now going to give my new and updated version of that antiderivative, meeting all the criteria, is x squared minus 3x plus 6. Because that equation not only has this derivative, but it also has this as a point on that final curve. Okay? So we're going to do the same thing on this one. I'm going to separate here. I did not make this a nice one. All right, so I know it's going to be dy, and I'm going to integrate this whole booger over here, which is 4e to the x plus 6e to the negative x plus x to the 1/2 plus 1 over 1 plus x squared, and then I'm going to have a dx there. We won't use this till the end. Okay? So I get y is equal to, well, e to the x is its own antiderivative. This is also its own antiderivative, but I end up getting a negative out front. Okay, the antiderivative of x to the 1/2 becomes x to the 3/2, and then I have a 2/3 out front. Okay, this is an arctan. Hopefully we recognize that by now, that it's an arctan of x. Plus c. All right, so now we're going to go plug in our values. Well, y is 5. When I plug in 0 here, I get 4. Plug in 0 here, oh how nice, I get negative 6. When I plug in 0 here, that becomes 0. And so plus the arc tangent of 0. And that's real plus c. Well, that's really saying where is the tangent 0 or where is the slope 0? Well, that's at 0. So that's just 0 also. Okay, so what do I get? 5 is equal to negative 2 plus c. So c is equal to 7. So the solution to this differential equation with this condition is going to be y is equal to 4e to the x minus 6e to the negative x plus 2/3 x to the 3/2 plus the arc tan of x plus 7. Okay? All right. So we got some slope fields here. I may not get through all these. I may have to do this as a part 2 because of time limitations on the video. So what we're really going to do is, actually I'm going to stop it now and I'll do that one as a separate video.